Welcome to BKW Physics. I'm Mr. McConley, and we're going to use this Slinky to show some of the different wave characteristics that we've talked about previously in other videos. The first one I'm going to start with is a pulse. A pulse is a single vibratory disturbance. So if I send one vibratory disturbance down towards Susan at the end, it'll bounce back in the manner that you're seeing. If I send a few of these in a row, it's called a periodic wave. Now in that first example, I was spacing them out. And in the second example, I'm going to run them all together. Okay? Either way, periodic wave. Now, transverse is what we've been doing up to this point. So transverse waves mean that the wave particles are moving side to side, while the wave's motion is from myself to Susan. So we can see that the wave is moving towards Susan, however the particles are moving from this side of the classroom to this side of the classroom as they move. Now longitudinal is very different. That's the next one we have to look at. Longitudinal is if I were to gather up a bunch of this Slinky and then let it go, and on the video it's going to be pretty hard to see this, but basically the people from the side here, what are you seeing as the wave goes by you?
Kind of like condenses.
Yeah, there's a condensed, which we call compressed part of the wave, and that compressed part of the wave will actually travel right down through the Slinky and then back again. And what you got to notice with any of these, with transverse or longitudinal, is that the Slinky might for a moment move forward, backward, right, or left, but when all is said and done, the Slinky is right where it began. The wave travels through a Slinky, it affects the Slinky momentarily, but the Slinky always ends up back to where it started. That's a key concept. The last one we have to talk about is actually wavelength. And wavelengths is going to be a little bit harder, so I'm going to set up what's called a standing wave. And then I'm going to ask Lou here to mark a certain part of the wave. Now this certain part of the wave, what we're going to be looking for is you're going to see a big crest and then a trough. And when it repeats the pattern, in other words, when the pattern looks like where my hand is again, you're going to mark that. That's going to be one wavelength. You up for that game? And I'll help you. If you're in the wrong spot, I'll kind of move you forward and backward. So I got to get my standing wave going here. You got it. You got it. What he's doing, if you're not able to see on the video or from where you're seated, he's basically, he's saying the wave pattern started here. I noticed it went up, it went down, and then it repeated itself right here. And if it's repeating itself, these 2 points are one wavelength apart, and the word is in, or the words are in phase. Those 2 points are in phase. Nice job, Luke. For today, physics.